Now when we consider the second example was minus a raised to n u of minus n minus 1. Here also we got similar z transform z upon z minus a, but ROC was mod z less than mod a. Now what was the nature of this particular signal? If you remember, we just for some time back we drew the waveforms. Minus n minus 1 starts from minus 1 and extends up to minus infinity. Now such type of signals are called anti-causal signal, and for anti-causal signals ROC is always interior to some circle and covers the origin. It will cover the origin, that means origin will be z equal to 0 point, so it will be interior to a circle. So that's what we got mod z less than mod a. That means it's a ROC, it's a region inside the circle of radius mod a. And very interestingly, when we took the third signal, which was the combination of the two, it was a raised to n u of n minus b raised to n u of minus n minus 1. So first part of the signal starts from n equal to 0, and the second part starts from n equal to minus 1, and that's how the overall signal covers positive as well as negative values of n. Now whenever a signal is non-zero for some or all positive and negative values of n, such a signal is called both-sided signal. And for both-sided signal, ROC is a region between the two circles. So in such a case, ROC will always be region between the two circles, and that's what we got. If you remember the ROC of this particular signal, its Z transform was nothing but, its Z transform was the combination of the two, Z upon Z minus A plus Z upon Z minus B, but its ROC was mod Z greater than mod A and less than mod B, which is the region between the two circles. So this is the conclusion that we want to draw from these three examples. Very important conclusion. I repeat, for causal signals, that means a signal which start from n equal to 0, ROC is always exterior to some circle, and for anti-causal signals which start from minus 1 and go up to minus infinity, ROC is always interior to a circle. If the signal is both-sided, that means if it is defined for positive as well as negative values of z, then ROC will be a region between the two circles, and these two circles will be defined with respect to the poles. Now if you have observed one thing, the circle that we are talking about is also the pole of each and every Z transform. I hope everyone knows the concept of poles and zeros. The pole for the first Z transform is nothing but Z equal to A, so the ROC is confined by the radius mod A. For the second case also ROC is Z equal to A. Now for this third case, there are two poles basically, Z equal to A, which comes from the first term, and Z equal to B, and that's how there were two circles and the ROC was region between the two circles. So that's one very important conclusion that we will use further. Let's continue with few more things about Z transform.